Now we are going to deal with a different type of cell. See, first of all, we started with electrochemical cell. Electrochemical cell. Okay, in electrochemical cell, we have chemical energy, that is by the virtue of a spontaneous redox reaction. And then we transform this energy to electrical energy. Now what we are having, we will be having electrolytic cell. Electrolytic cell. Here what we will be doing, we will be doing just the reverse. We will use electrical energy. And what we will do with this electrical energy, we will give this electrical energy to a chemical system, and as we give this to a chemical system, we will obtain a chemical reaction that is non-spontaneous. So if you want to have an analogy, then you can have an analogy of this. This is a pen. And with this electrochemical cell, what we are doing, we are dropping the pen from a height, and as we drop this, potential energy is decreasing. That means we can use this kind of potential energy to make some different kind of energy. We can move, we can drop this pen on a turbine, the turbine will move and it will generate electrical energy, right? And what is this? With this, you can give an analogy that you have a pen in your desk, okay, and you lift it up. So for lifting it up, you have to provide some energy, and this process is non-spontaneous, because if you drop the pen, it is spontaneously coming down. You don't have to provide any energy. But when it is down and you are not doing anything, it is not eventually going up. To make it go up, you have to provide an energy, correct? So this is the kind of analogy that you can have in mind, and then we can move further on. And yes, electrical energy is converted to a chemical reaction. This process is known as electrolysis. It is known as electrolysis. So first of all, let us define a few things, then we will start the main concepts. First of all, an electrolytic cell. What is an electrolytic cell? So the first phrase that should come in your mind is that electrical energy gets converted to chemical energy. And what does it mean by chemical energy? A reaction. That is a chemical reaction. Okay. So the first thing, that phrase that should come in your mind, the idea that should pop in your head is that in electrolytic cell, electrical energy is used, it is consumed to bring about a chemical reaction. And how should we define it in a formal way? Okay, so in electrolytic cell, external source of voltage, voltage is used to bring about a chemical reaction. A chemical reaction. And if you will remember, the electrochemical cell was just the opposite. What we used to do, we used to generate some voltage by a chemical reaction. For example, if we have this following reaction, Cu2 plus 2 electron gives us Cu solid. Okay. So what we are saying here is the copper ion, it gets 2 electron and then Cu is deposited. So where will this electron come from? This electron will come from the external voltage. What is electricity? What is current? It is the flow of electrons, right? So this is coming from where? The external voltage. And what we are doing, we are making a copper solid. So in this particular reaction, we can say that when a source, when voltage is applied, when voltage is applied to two electrodes, two electrodes, then Cu2 plus ion discharge at the cathode, and the following reaction and the above reaction takes place, and the above reaction takes place. So here we will have a battery. So the battery external voltage, and this side we will be having some, this is, let us say this is Zn, this is copper, so what is happening? The electrons, if you want to complete the circuit, then it would be like this. Then what is happening now? The current is flowing from this direction to this direction, correct? So oh, wait a second. The current is flowing in this direction. The electrons are flowing. The electrons are coming in the Cu position, and then what is happening? Cu is eating up the electrons and making Cu solid. Okay, so this is the kind of picture that you can have in mind. You don't have this type of picture in your syllabus, by the way. Now moving on, if we want to have a quantitative idea, correct? Till now, what did we have? A qualitative idea. Okay, fine. The electrons are coming, so Cu2 plus will eat up those electrons and make Cu solid. But what about how much solid will be produced? How much Cu will be produced? For that, we have, you can write quantitative study of electrolysis. This is called electrolysis, the process in which we use electrical energy to bring about a chemical reaction. That process is known as electrolysis, and it uses a cell which is called electrolytic cell. So it is given by Faraday's law. There's a scientist called, which is Michael Faraday, and he gave some laws of Michael Faraday's laws of electrolysis. Michael Faraday's law of electrolysis. So what I will say, Jubena, is that you leave a space in your notebook. Around, it has two laws. First law, and then second law. Okay, and you note these down from NCERT. What are these statements? Okay, what we will do, we will directly jump into questions, and we will know how to solve this question, and after that we will come to this. We will get an idea how to solve those questions, and from that we will get an insight how Michael Faraday came up with this law. Okay, so leave some spaces. I guess half a page will do. Leave half a page, and then we will start with directly a question. Okay, now if I say this question is a solution of CuSO4 is electrolyzed for is electrolyzed for 10 minutes. 10 minutes with a current of 1.5 ampere. 1.5 amperes. What is the mass of copper deposited? What is the mass of Cu deposited at the cathode? So how to approach this type of problem? Okay, a solution of CuSO4 is electrolyzed for 10 minutes with a current of 1.5 ampere. What is the mass of copper deposit at the cathode? Okay, fine. We have what I can say. Can I have your mic on, please?
Okay, sir.
Yes. So we want to measure how much copper is deposited at the cathode. Okay, fine. That means we can say that copper is forming. So if we will be having a reaction, then we will say Cu solid is forming. Okay, fine. Cu solid is forming. From where will we get the Cu solid? Okay, where else do I see Cu? What do you think, Jubena? Where else do you see Cu in this question?
CuSO4.
CuSO4. Okay, fine, great. So a solution of CuSO4. Okay, a solution. It is saying a solution. That means this in solution, the Cu will be present as Cu2 plus, and SO4 will be present as SO4 2 negative. That is why they are making a solution. If they will be dissociated, and if it is an aqueous molecule, then H2O will be solvating it like this. H. It will be coordinating this. Oh, sorry. This is the lone pair, na? Oxygen delta negative because of higher electronegativity. It will be surrounding the Cu2 plus, and the HS, which has delta positive, will be surrounding the SO4 2 negative. That is why they are getting solvated. They are getting solvated in this. Okay, fine. That means the Cu that we have, the Cu that we will have, it will be coming from Cu2 plus. Okay, fine. Now, what does this Cu2 plus need to get converted into Cu?
2 electrons.
2 electrons. Very rightly said. 2 electrons. 2 electrons. Okay. And where will this electrons come from? So where does see in the last slide also I told you na, these electrons are coming from where? That current, correct? So these electrons are coming from, this is from where? This is from CuSO4. We get this from where? We get this from
Current.
Okay, fine. Now you tell me how much CuSO4 do we have? Does the question provide you any information on the amount of CuSO4?
No.
No. But that means we can take it any much. We can take any amount. Now, does it tell any information about the current? How much current is there?
Yeah, 1.5 ampere.
1.5 amperes. Okay, fine. Now we have to convert this current into charge. Now do you have a formula that you can remember from your electricity, current and electricity? There is a chapter in current and electricity, right? In
Yes,
physics?
Yes, sir.
So Q is equal to current into
V.
time. IV.
I by V.
Okay, IT. No IT. Q is equal to IT.
No, I didn't use the
Okay,
V.
fine. You will confirm this. You will confirm this from physics. Okay, confirm from physics. Okay. Q is equal to IT. That I can say that the charge produced is the current in amperes, that is 1.5, into times in seconds. So how many seconds in 10 minutes?
10 minutes. 600.
Very right. 1.5 amperes into 600 seconds. This will give us, now this charge that we get here, is in coulombs. So what will be this much?
9.9 into 10 raised to 2.
Yes, you are right. 9 into 10 raised to 2, that will be equal to 900 coulombs. Okay, great. So that means we have, do you remember this term, limiting?
Yes, sir.
Limiting reagent, correct?
Yeah.
So this is a chemical reaction, right? And what is the limiting reagent here? The limiting reagent is electricity. Correct? The number of electrons, right?
Yes, sir.
That is the limiting reagent, and we determine the amount of product according to the limiting reagent, correct? We determine how much product will be forming by using the limiting reagent, because if A is there, B is there, for example, if I say giving us AB. Now, if I have this one as 100 moles and I have B only 1 mole, now you tell me how much moles of AB will be formed?
1 mole.
1 mole of AB, right? So what was the limiting reagent here? B.
B.
This reaction was limited only to a limit. Why? Due to the less presence of B. So now here we have, whole lot of Cu2 plus, but we have a limited amount of electrons. Hence we will calculate the amount of Cu solid obtained by using the electrons, by using the charge. Okay. Now the other thing that I want to emphasize here is, read this statement, read this chemical reaction. How will you read this chemical reaction?
Cu2 plus 2 electrons gives Cu solid.
Okay, fine. Now, now if suppose you are somebody who makes copper, okay? Now you want to sell your copper and you want to sell a plan that says that involves this particular reaction. So you need to quantify some things, na? You will let other people know, na? If you use this particular reaction, then you will get this much of copper. So how will you reformulate your sentence for this particular chemical reaction if you want to quantify it?
X Cu2 plus plus 2 electron gives XCU.
If you are using XCU2 plus, then we will be having 2x electrons, correct?
Yes, sir.
So a better way you can say that, and chemistry and this chemical reactions are written in such a way only. When you read any chemical reaction, you will read it like this: 1 mole of Cu2 plus 2 moles of electron gives 1 mole of Cu solid.
Okay.
Right?
Yes, sir.
Okay. So 1 mole of Cu2 plus 2 electrons give 1 mole of Cu solid. Now, what is the benefit of that? That we can start calculating the things. For example, I can say one mole of Cu2 plus require 2 moles of electron. Fine. So what is the tell me, 2 into what is the charge that is required? Charge required, because we know the limiting reagent that we have is in terms of charge, correct? It's in terms of Q, that is charge. So we want to know, okay, fine, electron is good, but what is the charge required? Charge required is equal to, is charge required to convert to or to deposit 1 mole of Cu solid. That means 2 into, what is the mole? Mole is 6.022 into 10 to the power 23. And what is the charge on 1 electron? You don't remember? Okay, fine. It's okay. 1.6 into 10 to the power minus 19 coulombs. Minus 19 coulombs. 2 into 9.63 into 10 to the power 4. Okay, coulombs. Mole inverse. This will be write it 2 into 9.63. Oh, sorry. If I want to remove this particular, then what I can do is 96300 coulombs per mole. Now, do you recognize this number?
No, sir.
No. This is 1 Faraday. This is 1 Faraday. What is 1 Faraday? 1 Faraday is approximately equal to how much? 96500. 96500. That you calculated 300. No? The exact value for 1 Faraday is equal to 96500 96487 coulombs. 96487 coulomb. We approximate it to 96500. So this is 2F. 2F. And what is F here? F is equal to 1 Farad. It is a Faraday is equal to the charge on 1 mole of electron. 1 mole of electron. The charge on 1 mole of electron. Okay, fine, great. So now we know if you want to deposit 1 mole of copper, we need how much charge? 2 Faraday's charge. How much charge? 2 Faraday's charge. And if you calculate this, then what will it come? Let us just keep it like this only. 2 into 96487 or 96500, approximated to 96500. I wanted to remind you of this Faraday charge. You don't remember zero in Nernst equation. We write it in 0.059 upon 2F upon NF. The F is what? That is the Faraday. No? That is the Faraday. Okay. Now what we will do, the next page is that we have this information that is, okay, now 1 mole of copper requires 2 into 96500 moles. Okay, fine, great. That means if we have 2 into 96500 coulombs, we will get how much? We will get 1 mole of copper solid. If we have 1 coulomb of charge, then we will get 1 upon 2 into 96500 mole of copper solid. Any difficulty till here?
No, sir.
No. Now, how much charge do we have, Jubena? We have how much charge? We have just 900 coulombs. Okay, so just the unitary method 900. If we have 900 coulombs, we will get how much? 900 divided by 2 into 96500 mole of copper solid. Okay, you got the answer as 0.0046. You just confirm it. It will be kindly approximately this much only. Okay. If I take your answer, then what I can say is, so this will be the number of moles. Now calculate. I have given you molar mass of Cu is equal to 63.5 grams per mole. Now calculate the mass of copper deposited. Mass of copper deposited. You have number of moles and you have the molar mass. Okay. Now calculate deposit. So mass deposit will be 0.0046 mole into 63.5 grams mole inverse. Now this mole will cancel each other and we will get the answer in grams. So what is the answer that you get? Yes, correct. I just saw this. 0.292 grams. 0.292 grams approximately. Yes, that is correct. So now let us move on to some other questions that we have. These are some simple questions from NCERT. How much charge is required? The charge is required for following. How much charge is required for the following? So if it says charge, then you have to tell me in terms of coulombs. In terms of coulombs. Okay. And if the question says how much charge in terms of Faraday, then you just have to give me the Faraday. Okay, fine. No, not solution. I just have to write the ABC part. ABC. A part is 1 mole of Al3 plus 2Al. The B part is 1 mole of Cu2 plus. Okay, fine. 1 mole of, let us say, Zn2 plus to Zn. C part is 1 mole of. Now this will, I will explain this one. Just do these MnO4 negative to Mn2 positive. Okay, see, what you can do here is, listen, Al3 plus 3 electron gives Al solid. That means, how will you, okay, Jubana, how will you read this chemical reaction? Tell me.
1 mole of Al3 plus 3
Three.
electrons.
Plus, not 3 moles of electrons.
3 moles of electron gives 1 mole of Al solid.
Okay, fine. So the important point that you said was 3 moles of electron. Okay, how much?
3 moles.
3 moles of electron. Okay, so charge on 1 mole, Q on 1 mole is equal to how much? Q on 1 mole is equal to 1 Faraday. So Q on 3 mole is equal to 3 Faraday. Now you have to convert this 3 into 9,6,500 coulombs. This will be equal to how much? So such a easy question, right? Or correct or not?
Yes, sir. 2895000.
2895. Yes, correct. 2895. How much zero? 30.
Yes, sir.
289500. Yes, approximate. Can you please tell me how much zeros? I guess 2 zeros will be there. No?
No, 30, sir.
I have written an extra zero here. It is 96500. 1 Faraday is 96500. No, I wrote an extra zero there. 96500. Correct. No. Then the reaction Zn2 plus 2 electron is equal to Zn. Okay, gives Zn solid. Now you will write okay, fine. Now, before going to this question, first of all, what you will do, we will try to analyze one more thing. Do you know anything? Do you know this term oxidation state?
Yes, sir.
Oxidation state, very good. If you know this term, then what do you think? Al was, what is the oxidation of aluminium here in the reactant side?
3 plus
And what is the oxidation state here?
0.
Okay, fine. And if we say the difference, the charge required, if I say this statement, will it be correct or not? A more appropriate statement would be, we don't even want to recognize the number of electrons. What we will say is, charge required is equal to difference in oxidation state into Faraday. Let us see and let us test this statement. Okay. Now, what is the difference in oxidation state? Delta OS is equal to how much?
3.
Here, 3. Okay, fine. We got 3F charge, correct?
Yes, sir.
If we test this here, then what is the difference in oxidation state? Delta OS is equal to
2.
2. Okay, fine, great. And we multiplied this by F. Fine. That means this is our statement is true. Okay, now if we check here also, here, then what do you think? The difference in
2.
OS is delta OS is equal to 2. So charge required Q should be equal to 2 Faradays. Let us see. Yes, we got it, 2 Faradays. Okay, fine. Now let us move on to this question. And I am just taking another side, 1 mole of MnO4 negative to Mn2 positive. That means we will require MnO4 negative plus some electrons, and I'm just writing here, this is, we want to find how many electrons, right? So, and it is converted to Mn plus 2. Okay. Now, what happens? We don't know the electrons. So we will not bother about the electrons, how much electron we are requiring. We will just do, we have a better formula. What we will say, charge required is equal to delta OS multiplied by Faraday. So now you tell me, what is the oxidation state of Mn in MnO4 negative here? What is the, so let us now tell this, MnO4 negative. We have how many atoms? We have 1 Mn and 4 oxygens. Okay, fine. So we don't know about manganese. We know about oxygen. Correct? Why do we know about oxygen? Because oxygen is a p block elements, and p block elements does not slow. And obviously, more than p block element, it is an element of second period. Now, the distinct thing about second period is that they show only one oxidation state. Their oxidation state do not vary. Correct? So what is the oxidation state of O will be the same in any molecule. For Mn, we don't know, because this is a d block element, and d block elements show variable oxidation state. Now there is only one manganese, so we will write X plus there are 4 oxygens. For each oxygen, there is a -2 oxidation state, and it will be equal to
0.
What is the charge here? This is a charge species, na, MnO4 negative.
Okay.
Yeah, NaCl, was it charged? No, that is why we wrote 0. The overall charge was 0, but now we have an overall charge on this molecule that is of a -1. So we will write -1. Now you tell me X is equal to how much?
7.
No, okay, fine. And what is the oxidation state here?
+2.
Okay, so I can write 7 minus 2
5.
into Faraday. This will be equal to how much? 5 Faradays. This will be equal to, now calculate 5 into 96500 into 96500 coulombs. A different set of problems, a different kind of problem. The problem is how much electricity in terms of Faraday. Question is, how much electricity in terms of Faraday is required to produce A part is 20 gram of Ca from 20 gram of Ca from CaCl2. The P part of this question is 40 gram of Al from Al2O3. Okay.
So, can you say first step to approach?
Okay, fine. I will ask you first step. What they have asked is,
Faraday.
huh?
How much electricity in terms of Faraday is required?
Okay, fine. So, what do you need? First of all, what do you need?
Q.
Okay, Q. For Q, what do you require?
I and T is needed.
Okay, fine. If I and T is not needed, we can calculate the charge in other terms also. What is given is 20 gram of Ca from CaCl2. Okay, fine. Let us look at that particular thing, if you cannot. So, what do you think? Where will you form Ca from? Where will that calcium will come from? The 20 gram of calcium that you want to produce will come from where?
CaCl2.
Okay, fine. So in CaCl2, in calcium chloride, do we have calcium chloride? In calcium chloride, do we have calcium as calcium or calcium in some other state?
In some other state.
What state is that?
Liquid.
It is molten. It is molten, so it will be liquid. From molten, it is molten. No, I'm talking about in terms of atomic nature. What is the difference between Ca calcium, which is a solid, and CaCl2? Okay, this calcium here, and this is CaCl2. What is the difference here? This is an atom. This is pure calcium. This is
Compound.
compound. Okay, fine. So what is the difference in this calcium and this calcium?
One is a mixture and one is pure one.
One is a mixture. No, this calcium is not a mixture. If I'm just talking about the calcium that is present in CaCl2, the calcium which is present in CaCl2, and the calcium which is present in the form of solid. What is the difference?
One is solution.
If I terms in terms of atom, if I take one atom of calcium from the solid state and one atom from the CaCl2, what will be the difference? No difference, or there will be difference. If I take one atom, there is no question about any phase, because solid, liquid, and gas, they all are ensemble properties. By that I mean they are defined by their neighboring atoms. If the calcium neighboring atom is very near to itself, very near to the calcium atom, then it is solid. If they are little further away, then we call it a liquid. If they are more further away, then we call it gas. But if I am taking one atom, there is no question of liquid, solid, or gas. Now you tell me. There will be a difference. Okay, fine. If I say NaCl, now this Na and Na solid, what is the difference?
For their charge.
Exactly. Na? The oxidation state. Correct?
Yes, sir.
So I can say that CaCl2, we will form from CaCl2. And CaCl2, Ca is present as Ca2 positive. Correct?
Yes, sir.
Now I will say Ca2 positive will give me calcium. Okay, fine. But where will this 2 positive charge, it requires how much electron? 2 electrons.
Yes, sir.
Correct? Now
Yes,
you
sir.
tell me the charge required.
2F.
2F. Okay. Now 2F will form how much? 2F will give me 1 mole of
C.
calcium. Correct? Correct.
Yes, sir.
Now that means I can say 1 mole of calcium. The molecular mass of calcium is how much? Don't remember. It is okay. 40 grams. 40 gram of calcium requires 2F. 20 gram of Ca, how much? 2 into 20 by 40, that will be equal to 1F. Correct?
Yes, sir.
Did you get it now?
Yes, sir.
Okay, now in this question, you require one thing, that is the mass of molecular weight of aluminium is equal to, I mean, if you are able to remember this, then remember these things, 27 grams.
3 plus 3.
Yes, correct. Plus 3.
So can you take last page?
Yes. Now another type of questions. Now another type of questions is that how much does it charge or electricity? Okay, here you don't have to do anything much. The only thing that you have to do here is for the first question. Sir, how to remember practice? Practice. The only answer is practice. First of all, what you do? Always solve those problems. Look at the molecular weight, and just repeat it a few times. Then again, in the next problem, if you face something, just repeat it every time. Just repeat it every time. Practice, nothing else. You cannot remember anything without practice. Okay, for the first question, 1 mole of H2O is oxidized to O2. 1 mole of H2O is oxidized to O2. Acha, Jubena, I have a question for you.
Okay, sir.
In H2O, what will get oxidized and what will get reduced? Can you say anything about that? If I say just H2O and if I want to oxidize it, if I want to reduce it, let's say reduce it, that means I want to add electrons. So what will be the product? Now you tell me, out of H2O, is it polar or non-polar?
Non-polar.
Yes, non-polar. That means it will be having which is more electronegative here, oxygen or hydrogen?
Oxygen.
Okay, fine. That means oxygen will be pulling the electrons, the bonded pair, and it will be getting delta negative charge, and these hydrogens will be getting delta positive and delta positive. Now you tell me, where will the electron like to go? In hydrogen or in oxygen?
Hydrogen.
Hydrogen. Why hydrogen?
Opposite charges are attracted.
Opposite charges. Okay, fine. So it will never go to oxygen. So if I say an electron is added, you will say the hydrogens are getting reduced. The hydrogens are getting reduced. Okay. And if hydrogens are getting reduced, what is getting oxidized? Oxygen is getting oxidized. Okay, great. So if you have any compound, then you will be easily able to recognize which of the atoms are going to oxidize or reduce. At least not a very in a quantitative way, but in a very qualitative way. Achha, ye atom will get oxidized and that atom will get reduced. Okay. For this question, we have H2 and then O2. Now you tell me, what is the oxidation state of oxygen in H2O?
-2.
Okay, fine. This is -2. What is the oxidation state of oxygen in O2?
-4.
-4. Do you see anything here as -4?
No, -2.
-2. Do you see anything here as -2?
No, sir, but then for oxygen, usually it's -2, right?
Yes, it is -2. Only when it is -2 and how it is -2.
When it doesn't have any other extra subscripts.
Why it is -2 and why hydrogen is not -2?
Yeah,
If either in
because
NaCl,
in H2O,
in H2O,
there are two opposite charges are there. So their bond pulling is there by oxygen.
mhm,
And in
that means
O2,
you want to say if we will break this bond, if we will break this bond and break this bond, the electrons will go with oxygen, correct? And then oxygen will get two more electrons and it will get negative charge, correct?
yes, sir.
Okay, fine. Why the electrons are going with oxygen? Because oxygen is more electronegative than hydrogen. What about O2?
It's single. It doesn't have. There is nothing to break. It's oxygen
No, no.
bond.
Yes, the delta electronegativity is the electronegativity difference is zero. Correct. That means the electrons are equally shared between these two oxygens. So what will be the oxidation state for these two oxygen?
Zero.
0 and 0. Okay.
Okay, sir.
So now tell me what is the oxygen state for O2 here is 0. Correct.
Yes, sir.
Now you can write charge required is equal to 2 into Faraday. This is equal to how much? 2 into 96500 coulombs. That is equal to how much? How much did we find? 2 Faraday is equal to how much? 193. 193
19330.
coulombs. Okay. Now let us go to the second question. CO. You have to do it to Fe2O3. Now tell me what is the oxidation state of Fe here?
+2.
Plus 2. What is the oxidation state of Fe here in Fe2O3?
3.
Plus 3.
Yes, sir.
So charge required is equal to how much Faraday? What is the difference?
1.
1 Faraday. That is equal to how much? 96500 coulombs. You want to copy this?
Yes, sir.
Copy. I'm writing another question here only. That's 520. So we have come to the last question on this series, that is the electrolysis and electrolytic cell. Now, this is a very important question. We have 3 electrolytic cells. This is one cell, another cell, yet another cell. And if we say we have this type of and electricity is passing in all of them. Electricity is passing in all of them of 1.5 amperes. This is A, this is B, this is C. Oh, Jubair, can I have you please in series?
Okay, sir.
In series, same electricity pass, same current passes, na?
Yes, sir.
Okay, that means all these will get 1.5 amperes. All these will get 1.5 amperes. But the switch was on for a minute. The switch was on, then it became off. Then it was turned off. And when it was turned on, we found that 1.45 gram of Ag was deposited. Okay. So
Okay.
see, now first of all, what did we have? We had the current, we had the time, and we had to find the mass of Ag deposited. Now we have just to find we have the current here, we have the mass here. Okay, so let me just tell you the track on how you should go. In the earlier question, like this one, this is the question. Here, what did we have? We had the charge. From charge, we found out what we had the current. From current, we found out how did we find the current? Current, we had current and time.
Given.
From current and time, we found charge. From charge, we found what? Mass. Correct. Now, what do we have? We have mass. Correct.
Yes, sir.
And then we have, what do we have?
Time.
Current. No, we don't have time. We have to find the time.
Okay, sir.
From mass and current, you will find the charge, and from charge, you will find the time. Correct. From mass, you can find the charge, na? Listen, if you can find the charge, if you can find mass from charge, if you can find mass from charge, then you can find the charge from mass also.
Yes,
Then
sir.
from charge to current and time. To charge to current and time. Okay. Yes, AgNO3 to Ag. Now tell me, what is the oxidation state here? Do you have any idea? See, NO3 negative is like this. NO3 negative. NO3 is in negative form always. Okay. So what is the structure? O, O. This O is also negative. This O is also negative. And then we have a double bond O here. This double bond O. Whenever you see double bond O, it will be neutral. Single bond O will be negative, and single bond O will be negative. And if you have nitrogen with 4 bonds, this will be positive. So what is the net charge here? Negative. What is the charge on NO3?
Negative.
NO3 is negative. NO3 negative. And X. This will be equal to, what is the whole charge on AgNO3?
Negative.
AgNO3.
0, 0, 0.
So what will be X? What will be X?
1.
Okay, so from +1 to, what is the oxidation state here?
0.
Charge required is equal to how much?
1
1
M.
farad for 1 mole. Correct?
Yes, sir.
Okay, now do you have any how to proceed further? I can say that 108 gram. That is the mass of Ag. 108 gram molar mass requires 1 Faraday charge. Or I can say not as 1 Faraday. Let me say it requires 1 into 96500 coulombs. Okay, can I say this?
Yes, sir.
So 1 gram will require
1 into 96500 by 108.
coulombs. Okay, and how many grams did we deposit? 1.45 grams. So 1.45 grams will require
96500 by 108 into 1.45.
Okay, calculate this. 1, 2, sorry. 1295.6 coulombs. Okay. Now you have the charge. You have the charge. What is charge is equal to?
I into T.
I into T. So you will write next thing. Q is equal to IT, implies that 1295.6 is equal to, what is the current given?
1.5.
Yes. 1.5 amperes into time. Now what I will say, time is equal to how much?
1295.6 by 1.5.
And this will come in what? Seconds. Now calculate this. What is this? 863.73 seconds. So this is the time. The first question you have done already. What is the time required? What is it? How long did the current flow? The current flow till 863.73 seconds. You can approximate it as 864 seconds. So how many minutes this will be? This will be equal to 864 divided by 60 minutes. So 6 ones are, then we have 26 fours are, then we have 24.4, 14.4 minutes. Just check this. Correct?
Yes, sir.
Okay. So first of all, you have the from electricity, from the current that you had, for that current you have the charge already now. Okay. The next question, what is the next question? You have to calculate the mass of Cu and mass of Zn. Don't need to do much. See, for Cu, it will be Cu2 plus 2 electron giving Cu. Okay. Now what will be the charge required? Q required is equal to 2 Faradays, that is for 1 mole. Q given is equal to, this is equal to what? 2 into 96500 coulombs. 1295.6. Okay, that means for 1 mole, 2 into 96500 gives us 1 mole. This much coulombs. 1295.6 coulomb will give us how much? 1295.6 divided by 2 into 96500. This will be equal to how much? Mole of copper. Now I can write the same thing as 1295.6 into 63.5 by 2 into 96500 and of this will be gram of copper, correct? 0.426 gram of copper. Now calculate for zinc very fast. Calculate for zinc. Okay, I have for zinc I have to give you the molecular weight. Weight of zinc is equal to 65.5, I guess, 65.5 grams. Yes, 65.5.
0.439.
Yes, what did you do? Instead of multiplying 63.5 here, you multiplied 65.5, correct?
Yes, sir.
Okay, so you got the answers. And now let us, I will tell you the Faraday's law. I will tell you the Faraday's law, but you will write it. Okay, you will write it from NCERT. You will not write it here. I will just tell you what are the Faraday's law that we have seen. Now, what is the first law? In each and every case, you saw that the amount of chemical reaction, that means how can we know amount of chemical reaction? By the amount of any metal that is deposited, 0.292 gram, This is deposited. Okay. Now all these amount of reaction that is happening is directly proportional to the what? Current passed. Correct. See,
Yes, sir.
the current for 20 minutes, then we would have gotten more copper. So this is the only this is the first law. Amount of
Charge.
chemical reaction. Chemical reaction is directly proportional to current or current passed or the quantity of electricity, I should say. What is charge? Quantity of electricity. If I say electricity, it will encompass both the current and the time electricity. Now, second law is a bit tricky. It says that amounts of different substance, amounts of different substance liberated by same quantity of electricity, liberated by same amount of electricity are proportional to their equivalent weights. Equivalent weights. And what is equivalent weight? Equivalent weight, the EW is equal to molar mass, which is divided by number of electrons required to reduce the cation. Number of electrons required. Okay, let us see this particular thing in the last example. Okay, fine. So for if I want to calculate the mass of copper is represented by this number, and the mass of this is mass of for Zn. Second, for Cu it is 1295.6 into weight of copper divided by 96500 into 2 electrons. And 2 is what is 2 electrons? It is the number of electrons required. For Zn it is 1295 divided by again 2 electron. What is this 2 electron? The number of electrons required for the formation of zinc. So from this and this equation, you can see that this particular terms, these two terms are same. Okay. So if you want to calculate, these two terms are same, and this depends. 1295 depends on the electricity. This is also electricity, and both these cells are having the same current as they are connected in series. So what is the thing that determines their deposited mass? It is the equivalent weight. This is what? Equivalent weight of what? Equivalent weight of copper. And this is of zinc.